In which of the following racemic mixture is not produced? And the reactions are given by, that is butane 2,1 reaction with hydrogen cyanide, and the cyclohexene connected with 2 methyl groups in the ring system on reaction with HCl, 1 butene on reaction with HBr followed by 3 methyl 1 butene on reaction with HCl. Whereas in this case of addition of hydrogen cyanide, here H plus and the Cn minus initiates the reaction, that is nucleophilic addition reaction takes place. Cn minus initiates the reaction in such a way that this is planar. sp2 in nature, sp2 implies what? It is planar. On this planar, Cn attack takes place in two different ways. Thus it results into the formation of what? OH can be dark side followed by, here our Cn can be dotted side can be possible, and followed by opposite way, that is here our OH can be present in the dark side, Cn attack occurs from the dark side. Like this, two varieties of products formation takes place. It is having chiral and chiral centers. One chiral center with two special rearrangements, that is enantiomers are formed. These enantiomeric mixtures are said to be racemic mixture. And moreover, in this case, electrophile will initiate the reaction, that is H plus. After initiation by H plus, this is secondary and followed by tertiary. Tertiary carbocation formation takes place. On that tertiary carbocation, that is sp2 in nature. Once again here, this particular Cl may attack from the dark side, may attack from the dotted side, that is two varieties of products can be possible. This will become methyl followed by this will become what? Chlorine. This is chiral center. So both varieties of chiral carbons are possible, hence this mixture will become what? A racemic mixture. If I go for the third case, here also carbocation is formed as intermediate, that is secondary carbocation is formed. On that secondary carbocation, Br can attack either from the dark side and Br can attack from the dotted side, hence here also what? Racemic mixture formation takes place. In the last case, here also, here carbocation formation takes place and it involves in rearrangement to generate the stablest cation. That makes the difference over here. After attacking of H plus over here, it generates stablest, that is relatively stablest secondary carbocation. Here it is having a chance to undergo rearrangement. From here, hydride ion is shifted to the carbocation place. Thus, it generates tertiary carbocation. On this tertiary carbocation, this particular Cl minus attacks in such a way that both varieties of attacks takes place, but it is having symmetry. I will write this product over here in the box. So therefore it appears as like this. Here methyl followed by here bromine is connected. But it is not chiral because it is having two methyl groups same. It is achiral. It is achiral implies this particular compound is said to be what? Meso compound. It is not the racemic mixture. The compound formed in this case is meso compound. That is meso compound. First case, one chiral center, two different varieties, that is mirror images are formed. This 1 and 2 are what? Optically active and are acting as mirror images to one another. This 1 and 2 are optically active and are acting as mirror images to one another. This 1 and 2 are also optically active and are acting as mirror images to one another. Hence, these three components related products are racemic in nature. Whereas in the last case, it is not having chiral center. As being it is not having any kind of chiral center, it is not meso. It is said to be what? Optically inactive. It is not meso. It is just optically inactive as a normal component. It is having plane of symmetry without having any chiral center, hence it is not known as meso, it is known as what? Normal optical inactive compound.